Retaining past electrical exam questions, particularly those from 1993, presents a unique challenge. While specific questions from that era may not be readily available, there are strategies and resources that can aid in exam preparation. Firstly, consider exploring the resources provided by the licensing board. Some boards maintain archives of past exams with sample questions. Even if the exact 1993 questions are not accessible, similar examples can provide valuable insight into the exam's format, difficulty level, and subject matter. Secondly, investigate online forums and communities dedicated to electrical professionals. These platforms often host discussions and shared resources, including potentially relevant practice questions or study materials. Thirdly, reach out to local electrical trade schools or apprenticeship programs. Instructors at these institutions may possess old exam preparation materials or be able to offer guidance on relevant topics. Fourthly, consider consulting with experienced electricians or mentors who have taken the master's exam in the past. Their recollections and insights can be invaluable in understanding the exam scope and focus. Fifthly, focus on understanding the fundamental electrical concepts and code requirements that are likely to be tested on the exam. This includes reviewing the National Electrical Code, specifically editions relevant to the time period, and studying key areas such as circuit calculations, wiring methods, grounding and bonding, overcurrent protection, and motor controls. Sixthly, practice with newer exam questions and sample tests to familiarize yourself with the current exam format and question styles. While the specific content may differ from older exams, the underlying principles and problem-solving skills remain relevant. Seventhly, consult with a qualified electrical instructor or exam preparation expert. They can provide personalized guidance and support based on your individual needs and learning style. Eighthly, review relevant textbooks and study guides covering electrical theory, code requirements, and practical applications. These resources can help reinforce your understanding of key concepts and prepare you for the exam's technical aspects. Ninthly, consider creating your own practice questions based on the topics covered in the National Electrical Code and other relevant resources. This active learning approach can enhance your comprehension and retention of the material. Tenthly, understand the exam format, time constraints, and scoring system. This knowledge can help you manage your time effectively and approach the exam with confidence. Electrical exam preparation often involves delving into complex calculations and understanding the application of various formulas. Let's review some key areas and calculations frequently encountered on electrical exams. Firstly, Ohm's law is fundamental. This law describes the relationship between voltage, current, and resistance in an electrical circuit. The formula is voltage equals current times resistance, often written as volts equals amps times ohms. Knowing this relationship is essential for solving many circuit analysis problems. Secondly, power calculations are crucial. Electrical power is the rate at which electrical energy is transferred in a circuit. The formula for power is power equals voltage times current, often written as watts equals volts times amps. Another useful formula is power equals current squared times resistance, often written as watts equals amps squared times ohms. These formulas allow you to calculate the power dissipated by a resistor or the power delivered to a load. Thirdly, series and parallel circuits must be thoroughly understood. In a series circuit, the same current flows through all components, and the total resistance is the sum of the individual resistances. The voltage drops across each resistor are proportional to their resistance values. The formula for total resistance in a series circuit is R total equals R1 plus R2 plus R3 and so on. In a parallel circuit, the voltage across all components is the same, and the total current is the sum of individual branch currents. The reciprocal of the total resistance is equal to the sum of the reciprocals of individual resistances. The formula for total resistance in a parallel circuit is 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3 and so on. Fourthly, understanding three-phase power is important. Three-phase power systems are commonly used in industrial and commercial applications due to their efficiency and ability to deliver high power levels. The formulas for three-phase power calculations depend on whether the system is Y-connected or delta-connected. In a Y-connected system, the line voltage is equal to the square root of 3 times the phase voltage, and the line current is equal to the phase current. In a delta-connected system, the line voltage is equal to the phase voltage, and the line current is equal to the square root of 3 times the phase current. The formula for three-phase power is power equals square root of 3 times voltage times current times power factor. Fifthly, conductor sizing and ampacity calculations are critical for ensuring the safe and reliable operation of electrical systems. The National Electrical Code provides tables and guidelines for determining the appropriate conductor size based on the ampacity of the circuit and the ambient temperature. Factors such as conductor material, insulation type, and installation method must be considered. Sixthly, voltage drop calculations are necessary to ensure that the voltage at the load is within acceptable limits. Excessive voltage drop can cause equipment malfunction and reduced performance. The National Electrical Code provides formulas and guidelines for calculating voltage drop based on conductor size, length, and current. Seventhly, transformer calculations are essential for understanding the operation and performance of transformers. The turns ratio of a transformer is the ratio of the number of turns in the primary winding to the number of turns in the secondary winding. The voltage and current ratios are inversely proportional to the turns ratio. The formula for transformer voltage ratio is voltage primary over voltage secondary equals turns primary over turns secondary. Eighthly, motor calculations are important for selecting the appropriate motor size and protection devices. Factors such as motor horsepower, voltage, current, and starting torque must be considered. The National Electrical Code provides tables and guidelines for determining the motor's full load current and the size of the overcurrent protection devices. Ninthly, grounding and bonding calculations are critical for ensuring the safety of electrical systems and preventing electrical shock hazards. Grounding provides a low impedance path for fault current to flow back to the source, tripping the overcurrent protection device. Bonding ensures that all metallic parts of the electrical system are at the same potential, minimizing the risk of electrical shock. Tenthly, short-circuit current calculations are necessary to determine the maximum fault current that can flow in a circuit under short-circuit conditions. This information is used to select the appropriate overcurrent protection devices and ensure that they can safely interrupt the fault current. The National Electrical Code provides methods for calculating short-circuit current based on the impedance of the circuit components. In addition to these calculations, a thorough understanding of the National Electrical Code is essential for success in the electrical exam. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years, so it is important to use the latest edition. The National Electrical Code is divided into chapters, articles, and sections, each covering specific aspects of electrical installations. Firstly, Chapter 1 of the National Electrical Code covers general requirements, including definitions, wiring methods, and grounding and bonding. Secondly, Chapter 2 covers wiring and protection, including overcurrent protection, conductor sizing, and wiring methods. Thirdly, Chapter 3 covers wiring methods and materials, including conduit cables and boxes. Fourthly, Chapter 4 covers equipment for general use, including appliances, lighting, and motors. Fifthly, Chapter 5 covers special occupancies, including hazardous locations, healthcare facilities, and agricultural buildings. Sixthly, Chapter 6 covers special equipment, including electric signs, elevators, and swimming pools. Seventhly, Chapter 7 covers special conditions, including emergency systems, fire alarm systems, and communications systems. Eighthly, Chapter 8 covers communications systems, including telephone, data, and cable television. Ninthly, Chapter 9 contains tables and examples for calculating conductor ampacity, voltage drop, and other electrical parameters. Tenthly, annexes provide supplementary information and guidance on various topics. When preparing for the electrical exam, it is important to study the National Electrical Code thoroughly and understand its application to real-world electrical installations. This includes being able to locate specific code sections, interpret code requirements, and apply them to solve practical problems. Another key area to understand is electrical theory. Firstly, atomic structure is a foundation. Understanding the basics of atoms, electrons, protons, and neutrons helps to grasp how electricity flows. Secondly, current flow is important. Learn the difference between conventional current flow, which is positive to negative, and electron flow, which is negative to positive. Thirdly, voltage is very essential. Understand voltage as the electrical potential difference or the pressure that drives current through a circuit. Fourthly, resistance must be known. Recognize resistance as the opposition to current flow measured in ohms. Factors affecting resistance include material, length, and temperature. Fifthly, conductors and insulators should be understood. Know the properties of good conductors, such as copper and aluminum, and insulators, such as rubber and plastic. Sixthly, series and parallel circuits are critical. Understand how components behave differently in series and parallel configurations concerning voltage, current, and resistance. Seventhly, magnetism and electromagnetism are also important. Learn about magnetic fields created by current-carrying conductors and the principles behind electromagnetic induction. Eighthly, AC versus DC circuits must be understood. Know the differences between alternating current and direct current, including how voltage and current vary over time. Ninthly, inductance and capacitance are also essential. Understand how inductors store energy in a magnetic field and capacitors store energy in an electric field, and their effects on AC circuits. Tenthly, transformers is also a factor. Learn how transformers work to step up or step down voltage levels in AC circuits based on the turns ratio. In addition to these theoretical concepts, practical skills are also essential for success in the electrical exam. Firstly, wiring methods must be known. Be familiar with various wiring methods, including conduit, cable tray, and surface raceway, and their appropriate applications. Secondly, termination techniques are important. Know how to properly terminate wires and cables using connectors, lugs, and terminals, ensuring secure and reliable connections. Thirdly, troubleshooting skills are critical. Develop the ability to diagnose and troubleshoot common electrical problems, such as open circuits, short circuits, and ground faults, using appropriate test equipment and procedures. Fourthly, motor controls must be understood. Learn how to wire and troubleshoot motor control circuits, including starters, contactors, and overload relays, ensuring proper motor operation and protection. Fifthly, control circuits is also essential. Understand how to wire and troubleshoot control circuits for lighting, HVAC, and other electrical equipment, ensuring proper system operation and control. Sixthly, safety practices are also important. Adhere to safe work practices, including lockout/tagout procedures, personal protective equipment, and proper use of tools and equipment, minimizing the risk of electrical hazards. Seventhly, reading blueprints and schematics should be understood. Develop the ability to interpret electrical blueprints and schematics, identifying circuit components, wiring connections, and system layouts, facilitating accurate installation and troubleshooting. Eighthly, using test equipment properly is important. Be proficient in using various types of electrical test equipment, such as multimeters, ammeters, and insulation testers to measure voltage, current, resistance, and insulation integrity, ensuring accurate and reliable measurements. Ninthly, code compliance must be understood. Ensure that all electrical installations comply with the requirements of the National Electrical Code and other applicable standards, promoting safety and preventing code violations. Tenthly, documentation is essential. Maintain accurate records of electrical installations, including wiring diagrams, equipment specifications, and test results, facilitating future maintenance and troubleshooting. Remember that continuous learning and professional development are essential for staying current with the latest technologies and best practices in the electrical industry. Take advantage of opportunities to attend training courses, workshops, and conferences to enhance your knowledge and skills and advance your career. The electrical exam is designed to assess your knowledge and skills in a variety of areas, including electrical theory, code requirements, and practical applications. By thoroughly preparing and understanding the key concepts and principles, you can increase your chances of success and become a licensed electrical professional. Remember to approach the exam with confidence, stay calm and focused, and take your time to answer each question carefully. Good luck with your electrical exam preparation.